Is Paul Coleman here?
I'm here.
Oh, hi. I would like to invite you to come and sit. You're giving the first talk also.
Yes. I don't know whether that's a good thing, because these 10 slides probably represent the insights of the last 10 years of my life, which is a bit sad really. But it's insights gained from the journey from a research scientist, then into a technology entrepreneur, setting up a company based on research out of Oxford University, and then as an early stage technology investor. So I suppose I'm wearing all of those hats, and the insights come in this presentation. And so Rajendra, who I must thank for inviting me, asked me to talk about some of the issues associated with funding innovative technologies in telemedicine. And I'm going to talk about telemedicine and point-of-care technologies, but what I'm not going to talk about is what a lot of the meeting is focused on, which is those things that support telemedicine programs, the infrastructure, the architecture, the networks, and the EMRs. I'm not touching on those. Rather, I'm going to talk about medical devices and diagnostics that can sit on the periphery, and they can open up the value in the health system by getting that scarce expertise out of the hospitals to primary care, getting the data back in a functional way to those experts, and removing the need for the clinical expertise by having robust technologies that can deliver quality healthcare in a safe and high quality way. And importantly, these technologies are agnostic to whatever platform they sit on, so they need to be able to talk to all of the things which I'm not talking about. And if you think about them in that way, then these devices and diagnostics are a subset of the broader medical devices technology space. And there is a big industry out there, and there are traditional ways of leveraging private sector money to commercialize them. So you need to have a competitive advantage, and you need to be able to build a compelling business case. And the things within that business case are obviously your unique selling proposition. You need to be able to have a defensible position so you can stave off competition. You need to be able to enter the market, scale, be profitable, and ultimately give a return on that investment through acquisition or flotation. So in that sense, telemedicine and point-of-care diagnostics are no different from the broader medtech environment. Just to place that in a bit of context, I'll talk about one of the technologies very briefly from our portfolio, Icona Technologies. It's a spin-out from Oxford University. It's a handheld 3D imaging device. We formed the company in 2006 and have subsequently raised over a couple of million of venture capital around a cracking management team. And it's focused on accurate and repeatable wound measurement and documentation. So that's the market it's focused at, and it's a software solution to what has generally been a hardware way of developing 3D models. So it becomes portable, it becomes point of care, it becomes easy to use. And as I say, its first incarnation is in documentation in a clinic setting. But we're interested now in bringing it to places like India as well as Western markets to unlock its telemedicine applications. So here's an example of the output. These are photorealistic 3D models of the wound, which you can zoom in, you can rotate, you can change the lighting. It's the next best thing of having it in your hand, and that immediately opens up telemedicine applications. The focus is on chronic wounds and diabetic foot ulcers, and so there's an obvious immediate transfer into Indian markets. But it's a platform technology for broader democratization of teledermatology, and they're the type of things we're looking at. But this is an example of that device. It's patented technology, it's got a competitive advantage, and we've leveraged traditional funding streams to get it out there. I think one of the themes from this conference and each of the conferences I've been to in the past couple of years is that there are global problems in health, and so no longer we think about developing countries and developed worlds, you know, the diabetes, coronary heart disease. They're the same problems, and increasingly it's the same solutions, be it in rural India, rural East Africa where we're working as well, or back in the NHS or the US. And that's because technologies, if they're properly deployed, can drive healthcare which is better, it's simpler, and it's cheaper. That means you can drive efficiency, you can deliver better quality healthcare to more people for less resources. And there's not a healthcare system in the world that doesn't want that to happen. And the sophistication of modern technologies means they're very simple to use, like the Icona technology. A nurse in a rural clinic in India, just as much as a clinician in Manchester Infirmary in the UK, they can both use it, so it's the same technology solutions. So same problems, same solutions. And I'm going to focus now on a subset of where those solutions are emerging. And that is from the vast amount of money spent around the globe each year on publicly funded research. It's truly enormous. 300 billion sterling each year. I don't know how many crow that is, but it's a hell of a lot. And I might be out by 50%, it may be 150 billion. It's still a lot of billions. That's a huge amount of endeavor developing technologies which provide the solutions to a lot of the medical problems that we see. And if we can harness that, that's our challenge. If we can harness, we can identify, pull through, leveraging the venture capital investment to deliver it to market, to scale, to penetrate, and return on that investment, then everyone benefits. So it all seems absolutely perfect. The problem is, it's a common problem around the globe, just how poorly the emerging technologies from that huge amount of money are translated from the lab, from the bench in the university, out into the real world. It's poorly done everywhere. As I say, my first experience on this with my colleague David Kelly is here, was spinning a biotech company out of Oxford University 10 years ago. Oxford is one of the best universities in the world for technology transfer, and yet the systems there are highly inefficient. If you're getting 50% of the commercializable technologies, you're doing very well. And that's Oxford, one of the best places in the world. You move away from there in the UK, and you're down to maybe 10% of the commercializable technologies making it out. Put that on a global level, probably over 90% of all the technological innovations developed from that huge public spend are utterly neglected. And the ones that get out there aren't necessarily the best. There's a lot of stochasticity, a lot of randomness about whether one technology makes it or not. And so if we can put in place a more systematic way of mining that huge solutions base, then we can unlock a lot of value in this emerging space. And going back to my academic days as an infectious disease epidemiologist, here's the ecosystem of where those inefficiencies lie. So you've got this huge amount of technical proof of concept that the public purse subsidizes each year. And the challenge is to filter down and get it out to commercial maturity, get it out into the clinics at scale, delivering patient benefit. And the way you do that is leverage venture capital investment around that technology, grow it so that it gets onto the attention of the big tier one suppliers of medical technologies. They acquire it, they scale it through their sales and marketing network, and everyone benefits. The problem is, it's incredibly inefficient. Those big tier one manufacturers, and I hope no one's here from GE or Siemens, hands up if you are, good. They are themselves conflicted. They have platform technologies, and the idea of cheaper, simpler, better is whittling down their bottom and top lines. Why replace? At best, it's only going to cannibalize what you're already selling into. And so you need to get over the hump of that by getting these technologies to a point where it's better for them to acquire rather than trying to suppress it. It's not a perfect system. They are not incentivized to bring through disruptive technologies. Venture capital. Venture capital works by reviewing lots and lots of business plans and looking for the one which is perfectly formed with the best management and a plausible model and invest in that. They do not look to rescue cracking technologies from bad business plans. It's not their job. They deploy money into management teams. Unless you've assembled a quality business proposition with the best world-class management, you're not going to get those boys to write a check. And the problem is, back in the universities, they do not have the skills, the resources, the time to spend that considerable amount of effort and expertise to build that quality proposition. The vast, vast majority of those technologies, which if you could invest that time and resources, never make it into a quality proposition that a VC can write the check into. And that's my big insight from 10 years. It's not rocket science, but it's the way of the world. And so what we did was set up H2O Venture Partners based on this insight. And it's to fill that resource gap between this wonderful solution set and the needs which are out there. And the way we do it, we can't go to every university in the world and say, what have you got, and then run with each one that gets us excited. Rather, what we can do is get the insights from the end users, the clinical end users, those people who aren't conflicted about what the solution are, rather the people who are motivated to use the best solution wherever it comes from. If you start with need, you can then go and interrogate that huge amount of technical proof of concept which the public purse has subsidised. And using modern technology, information technology, from a desk in Oxford where we're based, we can look through the global publications, whittle down to those which are most exciting, run those by our partners, and if you choose your right partners for rural India, like Narayana, like Aravind, as we're working with Dr. Kim on similar processes, you can get your solution set to those needs. And remember, those needs are common across rural India and the rest of the global healthcare system. Then what you do is, what is the core of H2O, is you put in that additional expertise to turn that raw technology, which has been validated against the market need, into a quality business proposition. It's not rocket science, but it's not trivial. It's a lot of hard work from experienced technology entrepreneurs, people who have done it before, people with the technical and the commercial capabilities, so that you can put those solutions together with the right management, with a demonstration that they're going to be adopted in the market, so that people will write those checks for a couple of £1 million and get them out there and into the marketplace. So that, in summary, is the opportunity to bring through the new set of telemedicine and point-of-care technologies. They're not different to other medical technologies, but they are an exciting subset because of this commonality of problems they're addressing. And if you can get it right, you can cherry-pick the best technologies, accelerate them to market because they're based on the needs of the adopters. And there's a wonderful synergy to be unlocked between accelerating things into what I'm calling social markets, rural India, rural Africa, where you're delivering a huge amount of immediate impact by accelerating delivery of those technologies. If you can get them into the hands of the right people, like Aravind, you can unlock a huge amount of immediate impact. But that scale and demonstration of operational ability means that you can then go and hammer on the door of the NHS and say, why aren't you adopting this? They will adopt, and then you unlock commercial value as well, and it's synergistic. And that's what we're trying to do within the Chariot Fund for Impact Investment, which is H2O's latest fund, which is a collaboration with the London School of Hygiene and Tropical Medicine to provide that network into developing countries, with partners in India who provide the insight into medical need, people like Aravind, and with a steering committee who we had the inaugural meeting this morning, which includes Lord Crisp, Rajendra Gupta, Krishnan Gamathapi, and Dale Alverson, amongst others, so that we are really working to bring the best solutions to identified needs and then bringing the market forces to bear to deliver sustainable impact as well as commercial returns. And that's me. That's done.
Thank you. Are there any questions? Paul? Yes.
So, Paul, are you funding ventures, which are starting in India as well? Do you have any plan?
So within the remit of the fund, of the Chariot Fund, yes, we will look at that. We will come to them based on need, but we're agnostic to where those solutions may come from. A solution doesn't necessarily have to come from any one jurisdiction to be beneficial to that jurisdiction and the rest of it. And so, yes, we are. Its short answer is yes.
The second question, the 3D imaging device
Yes.
that you showed us, is that commercially available now? Or?
It's commercially available. It's just been launched, so it's got FDA and it's going through European CE marking. And Brian Holcroft, who's behind you, has a demonstration model with him. And so we are looking at opportunities in India as well.
What would be the price cost of one such one?
I don't know. I'll give the management a call and ask them and tell you later. But it's affordable.
Can I have the next